So good morning, everyone, and welcome to today's webinar on Ansys Cloud and HPC. My name is Milad. I'm application engineer at Alpha Omega, and this webinar will be presented by myself and my colleague Ali, who is our FEA application engineer. So let's get started. Agenda for today. First, I'm going to talk about Ansys HPC, and then Ali will present Ansys Cloud, and at the end, I'm going to show you a demo of cloud workflow using Ansys Fluent. Let's start with HPC. What is HPC? High performance computing using your own computer that has multiple cores. So by using Ansys HPC, you will be able to unlock additional cores for your simulations to speed up your solve time or even your meshing time. Ansys provides three options for HPC. The first one is standalone HPC licenses, which is a basic option and is typically used for low-level HPC. The second option is HPC Pack, which provides large-scale parallel processing for high-fidelity individual runs. And the third option is HPC Workgroup, which offers volume-discounted parallel simulations for multiple users and multiple runs. Let me explain each of them in more details in the next couple of slides. Option 1, standalone HPC licenses. Again, this is a basic option for low-level computing. For example, when using only 5 or 6 cores, this standalone HPC option might be suitable for your case. Each core in a parallel run consumes 1 HPC license. For example, if you buy 3 product licenses and 6 standalone HPC licenses, and let's say there are 3 users, if the first user solves on 4 cores, he or she only uses 1 solver license because the default number of cores is 4, meaning that you can use up to 4 cores without consuming your HPC license. And if the second user solves on 6 cores, he or she consumes 1 solver license plus 2 standalone HPCs. And in a similar way, if the third user solves on 8 cores, he or she consumes 1 solver license plus 4 standalone HPCs. So obviously this standalone HPC becomes expensive if used for large number of cores, and that's why other options are available. And the second option is Ansys HPC Pack, which provides large-scale parallel capabilities on individual runs. If you see this chart on the bottom right, it says that adding HPC Pack every time quadruples 8 cores to be added to the built-in default 4 cores. For example, by using 1 HPC Pack, the total number of cores that you can use will be 4 plus 8. So the total will be 12 cores. And if using 2 HPC Pack, the total number will be 4 plus 32 equal to 36 number of cores. But the cores cannot be split across multiple runs or combined with individual HPC or HPC workgroup licenses. So if, for example, if you buy 3 product licenses and 2 Ansys HPC Pack, if the first user solves on 12 cores, he or she consumes 1 solver license and 1 HPC Pack. And if the second user solves on 10 cores, he or she consumes 1 solver license plus 1 HPC Pack. So no matter what the number of cores he or she will be used, the 1 HPC Pack license will be consumed. And the remaining tasks, the remaining 2 cores to the second user are not available in the pool to the others. And this is a third option, Ansys HPC Workgroup, which provides large-scale parallel capabilities, and also you can share the cores among multiple users and multiple runs. And it's available in blocks for 16, 32, 64, and doubling up to almost 33,000 processors. And as I mentioned, cores can be shared across any number of simulation tasks and users. So this is beneficial where there are multiple number of users and multiple number of simultaneous runs. And as you see in this example, if you buy 3 product license and one Ansys workgroup of 16 license, the user number 1 can use 10 cores, and the remaining tasks are still available to other users. So by using 10 cores, the first user can consume only 6 out of 16 workgroup HPC tasks, and user number 2 can consume 1 solver license and 6, and similar things to the third user. So the remaining tasks are available in the pool to the other users. Ansys Cloud. So from now on, I will pass it over to Ali for his presentation.
All right. Thanks, Milad. I appreciate it. And great stuff on the HPC side. So basically on the HPC, you can use the cores of your machine to increase the speed of your pre-processing, including meshing, all the way to solving and post-processing. And now, if you want to use more cores, let's say 200, 300, or 400 cores, Ansys provides you a subscription-based platform, which call it Ansys Cloud, that you can basically have that subscription and use that number of cores. And let's see what products are available and are supported by that subscription. The first one is going to be Ansys Mechanical and Fluent and HFSS, Maxwell. And basically, if you look at it, a wide range of Ansys platform is supported by the cloud. And in different versions, starting from 2019 R2 all the way to the most recent one, which is 2021 R1, they're all supported by Ansys Cloud. And you can use up to 700 RAM, up to 1,000 number of cores, and it's going to be super, super fast. And for using and providing you a huge number of cores, Ansys is teaming up with Microsoft Azure to deliver reliability and fast computing. The first thing that most of our customers are concerned about is going to be the security. The first thing is regions and geographies. So basically, Ansys has servers from California in the US coming to Eastern USA, and we have some, and Ansys has some server in Europe and Japan. So basically, you can select those servers based on where you are. And coming to data residency, which persists based on the selected region, data retention and deletion policy. Each customer is solely responsible for their data retention and deletion policy and procedure. And availability, the Ansys Cloud Service application is deployed in multiple regions to achieve high availability and penetration testing. Security controls are addressed by Microsoft through their platform as a service. And I should mention here that this Microsoft Azure is ITAR certified, which stands for International Traffic in Army Regulations. And this is how we deliver the security in terms of the servers of our Microsoft Azure. And now let's talk about the cost. So the whole reason of doing the simulation is because we want to know what's happening to our model before doing the actual testing. And for simulation, a lot of times it happens that the analyst will have to cut corners to make some assumptions, some simplifications, or run it for fewer design points. This is because simulation can be very expensive in terms of time, in terms of a lot of details into your simulation. And what Ansys Cloud brings to the table is you don't need to simplify your model. You can deliver as much accuracy as possible for your simulation by using Ansys Cloud to use less time, to save a lot of cost, and have a seamless workflow in terms of sharing your file, and everything is in one platform. It's not like on different machines if you have Ansys in multiple machines within your company. So Ansys Cloud will make sure that it is a seamless platform, uniform, and secure and fast. And it's pretty effective based on the survey that we've done with our customers. So in older days, the more powerful the local machine was, it was pretty good. We could have a lot of CPUs and a RAM, but also those machines are expensive. And after some time, let's say using it 1, 2 to 3 years, a lot of new CPU generation will come, and a lot of new generations of RAM will come. And basically after 1 year or 2 years or 3 years, your machine will be outdated. And you don't need to be worried about those type of specifications of your machine to do the pre-processing, solve, and post-processing if you have the subscription to Ansys Cloud. And if you look at this picture for now, on the left, if the user is using 8 CPU cores and 8 GB of RAM and running one job at a time, it's going to take 8 hours per design point. So if you do 10 design point, it's going to take you about 80 hours. So for the most part, you don't get to have the best design point on the first simulation. You're going to need to run multiple simulations, and that means that you're going to need to spend a lot of time on each of those design points. And if you have the Ansys subscription for the cloud, you can use 132 CPU cores, over 1,000 gigabytes of RAM, and you can run 10 jobs at a time. And it's going to take you, all of them, it's going to take you 6 hours. So it is saving you a lot of time. And the user experience is identical, and Ansys and Microsoft handle all the IT. So you don't need to be worried about if you have multiple machines, if you need to, how you can basically use all the cores on different machines, and how from networking standpoint it's going to work. If you're working from home these days, you don't need to be worried about any of the IT stuff. So using Ansys Cloud, the benefits are increasing simulation throughput, pay for only what you use, access the latest hardware, saving a lot of cost, and focusing on engineering, not maintaining the cluster. After 2-3 years, you don't need to be worried about updating your CPUs or RAM. Microsoft will take care of the servers, and you don't need to be worried about that. And now let's talk about the workflow. If you have the Ansys Cloud subscription, what happens is it is going to add only one tab on your, let's say if you're using Fluent, in your Fluent. If you're using Mechanical, one extra tab will be there, and you can submit your job and do all the pre-processing from your computer. So it's not a totally new platform. You don't need to learn a new thing. It is the exact same thing. What you need to be worried about is how many cores you're going to use, and what server you're going to choose to run your simulation. And you can do also the post-processing on cloud as well. Here's on the left, it is going to what it's going to look like. So if you have the cloud subscription, and you are, let's say, simulating a CFD simulation. Here's on the job name, you can select your job, you can select your region, you can select your machine type, and then number of nodes and number of cores, and just hit submit. Ansys will automatically upload your file to the cloud, solve it, and will download it back, and you can see the results. And you can have control over the jobs. So you can see how many jobs are using. You're going to have 1 terabyte of cloud storage. You can see how much of that is being used. And there are a bunch of data and statistics that you can monitor your simulation. And you can share it with your colleagues. So if you're working from home these days and you're doing your simulation, and then you're going to send your model to your colleague, if the simulation file is big, then you probably are going to be in trouble. But one thing Ansys Cloud is offering is sharing the file and sharing the simulation from the cloud. So you don't need to upload it anywhere. You don't need to do anything extra. Just put the email of your colleague and send it out, and you're all set. And now, what we talked about for the most part was the hardware side of the story. What about the software side? Once you subscribe to Ansys Cloud, what happens is Ansys will provide you, which might be an additional cost, which is called AEC, Ansys Elastic Currency. And while you are working on the cloud, those AECs will be solved for your simulation, for the solve in your simulation to be done. So basically, you are going to need the Ansys Cloud subscription plus the AEC to be able to do the simulation and do the solve. But AEC doesn't only belong to the solve. You can also use it as an alternative to open an extra software on your computer. Let's say you have only Ansys Fluent and you have only the CFD package within your company, and there is a mechanical project coming up. You don't need to go and purchase an extra seat of mechanical if there is only one project in the whole year. You don't need to be worried about that. Or if there are other packages or other software that you're going to use, LS-DYNA or other Ansys platform software, then what you can do is you can purchase this AEC that not only is going to be used for your Ansys Cloud to solve your model, but also these AECs can be used to open other Ansys platform products. So this AEC will be consumed to open mechanical, to do some work on the geometry, let's say space claim. And these AECs can be used for pre-processing in other Ansys software as well. And locally, you can monitor that. You can see what's the rate of using those AEC, which is pretty low. And one AEC pack, depending on how you use it, it can last you a couple of months to a year, and you can leverage and use all the Ansys platform. And there are a bunch of statistics and data that will help you to set those goals within your company in terms of budget and everything to make sure that you are not using it all and you have enough information with regards to that. Now, in terms of saving some time, here is one benchmark. This is a flange that internally we've done some testing. And from 20 to 25 once we ran it and we checked it with the cloud, it used only 2 to 4 hours. So basically, it is 5 times faster simulation turnaround. This is a benchmark that I have done it myself. On the left side, you see that there is it is my own computer that I used. So I used one node, 5 core, 64 gigabyte of RAM, and I have 1 terabyte local space availability. And on top, you should see that my number of nodes is about 1 million, and the number of elements is about 227,000 elements. And my computer, by overclocking, it took about 1 hour. And on the right side, I used cloud, the same project, same everything with the same setting. I used 172 core, 2 cores plus 700 GB of RAM, and with the availability of cloud space, 1 terabyte. It used only 15 AEC, and it took only 16 minutes to solve this problem. So let's say if you are using about 1 or 2 simulation a day over the course of a week, you're going to use roughly about 1 week, you're going to use about 4 hours. You're going to save about 4 hours. And within 1 year, you can use up to a month. You can save up to a month on these specific small projects. I'm not talking about more sophisticated and complicated projects. Here is another example of how we save time from if you use 12 cores on this simulating and extracting the drag coefficiency here on a plane, initially using 12 cores, it will take on your local machine 5 hours and 27 minutes, which if you use clouds and use 704 cores, it's going to take you only 13 minutes for this huge problem to be solved. Here is an electric motor. 18 million hybrid conformal mesh and about 1,000 iterations. If you use 4 cores on your machine, it's going to take you 9.7 hours to solve this model. And if you use Ansys Cloud using 110 GB per node and 112 cores, it's going to take you only 31 minutes to solve it, and it's 18 times faster. Here is another example for HFSS, which is an RFICs board, and it is mainly used for meshing, and it generated about 100 million mesh, 100 million element in about 2 hours, which is a huge number of elements. Here's another example of HFSS benchmark for that RFICs. And if you look at here, using 32 cores and 512 GB of RAM, it used about 1 hour to solve this on a local working station. And if you use cloud, it's about half an hour, which is 2 times faster than big working station. And these numbers are different depending on how you set up your model and what you're looking for and the number of elements. Here is a 5G antenna that we used, Ansys Cloud, and it is 1.5 times faster. It took only 13 minutes to solve this problem. And you saw all this great stuff, HPC and cloud. You can ask for a free trial for both of them. You don't need to have any commitment. You don't need to pay anything, but you can request your free trial. Just send us an email and we'll be happy to provide you with a free trial to test it on your own projects and have a sense of how it's going to help you. From our standpoint, we helped a lot of our customers and they were pretty happy with the workflow, with the time that they're going to use and with the cost. And this is not only on the simulation cost, but it is also if you have a product in your manufacturing line, you're going to have better product because you can do much more design points. So you're going to save a lot of costs in your manufacturing line as well. With that being said, we have more webinars coming up. We're going to talk about Granta Selector, which is a material database for Ansys, and we're going to present how you can choose your material and how it's going to help you to select the material out there, do your simulation, and go out and buy the exact same material that you've done the simulation with. Thank you very much. Is there any question? Feel free to unmute yourself and ask your question if you have any. Alrighty. So I'll pass it to Milad. And Milad, if you don't mind doing a small demo, that'd be great.
Yep. Thank you, Adi. Can you confirm if you're able to see my screen?
Yes, I can.
All right. So thank you for your great presentation on cloud stuff. So I'm going to quickly show what's the workflow looks like using Ansys Fluent to submit a job to Ansys Cloud. So what we're gonna do, just we need to set up our model like we typically do in Fluent, and once everything is done, before and setting the number of iterations and everything, before clicking on calculate, on the top right there is an additional options called ACT. We need to activate that option, and Ansys Cloud option is right here. So by clicking that Ansys Cloud, you will need to use your username and password, just like what the credential you use to log into customer portal. And this new panel will pop up. So what we're gonna do, we're gonna click on new job here, continue. And then there's an additional option that we need to put the information. The first one is job name. So let's say cloud. And then the second thing that we need to specify is region. There are multiple regions worldwide, so generally it doesn't matter which locations you use, but people typically use the region that they're located. So let's say East US, and then machine type. There are multiple machines with different configurations. So each one has its own specifications. For example, this HC44, which is the recommended option here, has the total maximum number of 44 cores. But if you, for example, select other machines like HP60s, the total number of cores will be 60. So each one has its own configuration. So I'm going to use the HC44 here. And then you need to specify the number of nodes. So you will be charged for the number of nodes and not the number of cores. So I'm going to use only one number of nodes here, and using the maximum number of cores. So essentially, by increasing the number of cores, you will have the faster solver time. So 1 nodes and 44 cores, and then the next settings is the time limit in hour. So for example, if you want to stop your simulations after, let's say, 2 hours or 3 hours, you can specify that here. But if you put it 0, which is default, it means the maximum time limit, which is going to be 7 days. And then you have the option to download results after completion. And by choosing that option, you need to specify the directory on your local machine. And then some advanced option for TUI command. So for some like customized solution, if you're using UDFs or some subroutines, you may use this option as well. So that's pretty all. And then the last thing is just click on submit job, and what it will do, Fluent will take your case and data files from your local computer to Ansys Cloud. So it typically takes a couple of minutes, and you can monitor what's going on here. But after submitting your job, it's better to go to the cloud portal, to online cloud portal. You'll have the more options there. So let me show you cloud portal here. So here's my dashboard in Ansys Cloud Portal. So cloud.ansys.com. Just put your username and password, and you will be directed to this portal here. In here, for example, since it will take some time to find the machine, I'm going to show you the job that is already completed. So I've completed this demo before. So here you can check the status of your job, all the way from uploading, computing, and downloading your results. And on the next tab, which is text monitor, you can see the informations this information here is the exact information that you usually see in your Fluent console. So exactly the same. You can check that information here as well. And also in the graph monitor, you can check the residuals plot and also some other informations like CPU and memory usage. And some general informations like the solver time or upload time, and some general informations as well. And on the files tab, you can create folder, upload, or for example, if you select this input folder, you can download that selected just that selected folder to your local directory as well. So you have the full control here, and also you can do post-processing. There are two options for post-processing: view results and VDI post-process. The difference between those two is the view results just show you a quick overview of your results in the Ansys Cloud, but like this. So there's a Microsoft platform that will offer some quick post-processing. For example, in this case, just a brief overview of temperature contours here, and once you're satisfied, you can download your results to your workstations. But if you want to have the full post-processing and exactly like what you would do in Fluent, you have that option as well. So which is VDI post-process. What it will do, it will connect you to a virtual machine somewhere in the world, and you will launch Fluent there, and you can do a comprehensive post-processing before downloading the results to your local computer. So as you can see, you need to specify the machine and the version and everything, and then it will take some time to find a virtual machine somewhere worldwide. And the last thing I'd like to mention is you can run 5 number of jobs simultaneously. So right now I'm running 3 out of 5 jobs. You can check the status here, and 1 terabyte space is available to you for your simulations. So that's all in terms of Ansys Cloud demonstrations, and thank you very much for your attention, and feel free to unmute yourself if you have any questions.